Here we've got three equations: x plus ay equals 0, y plus bz equals 0, and z plus c x equals 0. And we're asked to find the conditions on ABC that give the different types of solution sets. So a unique solution, no solution, or infinitely many solutions. So first of all, I don't really like the way the equations are written here. So I'm just going to rewrite them in a nice way that lines things up. So x plus ay, and I'm going to leave a little space for z. And then I'll have y plus bz equals 0. And then cx I'll line up, and then plus z equals 0. And just the reason I do that is because it puts it into a matrix really, really nicely, which pretty much going to put every system of equations into a matrix. So I might as well do that. So my x's, my y's, and my z's here, and zeros down the right. And so I've got my matrix, and we're trying to figure out, again, no solution, one solution, infinitely many solutions. And I know that the reduced row echelon form of the system of equations will give that information to me generally pretty quickly. So I'm just going to use Gaussian elimination to get this into reduced form, and hopefully I can make my conclusions from there. So first off, I'm going to use my leftmost pivot, the 1, to eliminate that c below it. So I'm going to reduce it. I'm going to subtract c of row 1. And I have to be a little bit careful because I'm multiplying through without a number, but a constant c, but that's c minus c. It's going to be 0. It's going to be 0 minus a times c. So I'll get negative ac here. I'll have 1 minus 0, and then 0 minus 0. And then don't do anything to the other two rows. And now I'm going to use this leading one here to eliminate the minus AC and the A. And so it's just kind of going to be coefficient matching here. So I'm going to do row 1. It's going to be row 1 minus A of row 2. And row 3 is going to be row 3 plus AC of row 2, because that's going to wipe out the negative AC. And so I'll just rewrite the second one. And so I'm going to have 1 minus a times 0 is 1. A minus a, the whole point of that is getting my 0. And then I have 0 minus a times b, be negative ab. And then 0 minus 0 times a, which is 0. Notice with the zeros on the right, I'm adding and subtracting multiples of other zeros. Like there's nothing I can do to get anything that's not 0 here. So the rightmost column is just going to stay zeros. I'm going to do the third row. So row 3, 0 plus AC times 0 is 0. Negative AC plus AC, the whole point is getting the 0. And then what I have is 1 plus AC times the second row, AC times B. So I'm actually at 1 plus ABC here. And then 0 plus AC times 0 is 0. And I could, at this point, potentially divide that last entry there to get a 1, like we like in reduced row echelon form. There's a little bit of a snag in that I've got variables there, and I don't know what those variables are. I can't necessarily divide by something if it's 0. So if 1 plus ABC happens to be 0, I can't just divide that thing out. And that's kind of where we're at right now, is I don't know what this is. So I was good with these. Those are 1s. 1s are what I want. They're constants. They're not 0. But I don't know the value here. And the answer to our question of what type of solution set we get is going to be totally dependent on what that value is. So if you remember, the 3 things that we're looking for the types of solution sets are if we have like 0, 0, 0, and then not 0 here, then that means there's no solution. If I have actually all pivots, and in this case here, what I would need for that would be 0, 0, and like I'd have to have not 0. and then I could have really anything here, doesn't matter. Then that would be a unique solution. And the third case is if there's I don't have the no solution case, so there's like no solution case, so as above. And non-pivot columns. So phrase that a little bit differently, and there are non-pivot columns. So free. And in this case, the only way to get a non-pivot column, since the first and the second row, first and second column are pivots, is if that third one is not a pivot. That means that what we actually have here is a 0, 0, 0 and 0 case, and that would give me infinitely many solutions. And note that we can't actually have the first one because it's 0 on the right. So we actually get absolutely no case where there's no solution, but we are able to generate the other two. And I do know that this has to be 0. It doesn't matter if it's 0 or not for that case, but because we have a 0 here, it's going to be 0. So really, these are the two things we're looking for, is what conditions could we have to make those two things happen? And basically it has everything to do with the value of the 1 plus ABC. So if 1 plus ABC equals 0, then what we have is that the third column is free. And we have infinitely many solutions. And if that's the case, then what I would do is just let Z be T. And then row 3 is going to tell me that Y plus B Z, which is T, is 0. So Y is negative BT. And then that was row 2, not 3. And then row 1 tells me that X minus AB times Z, which is T, is equal to 0. So X is ABT. So what we have here, if ABC equals negative 1, then X is ABT, Y is negative BT, Z is T for any choice of T. So this is one answer. Now if ABC is not negative 1, then 1 plus ABC is not 0. And that means that we can actually divide by it. And then basically, yeah, what we end up getting here is that Z equals 0. So I'd have whatever this thing is, which implies Z is 0. And then if we look up at row 2, that means that X plus 0 is 0. So, Y plus 0 is 0. So Y is 0. And row 1 says that X minus AB 0. So X minus 0 is 0. So X is 0. So we get X equals 0, Y equals 0, and Z equals 0. We get the unique solution. And so those are basically the only possibilities that we get for this one.